Very good people. Let us look at this equation on hydraulic. Okay, mm, that would be activity 5.1, number 5. The following data refers to a single acting hydraulic press. A diameter of ram. So with it, the diameter of the ram it is given. The big D it is given. Big R it is given as 0.4 meters. Then the small d, it is given as 0.08 meters. We are given the stroke length, it is 0.12 meters. Then we are given the MA, mechanical advantage, as 40. Now they want us to calculate the F effort that must be applied to the handle. They want us to calculate the F effort if the mass it is given as 3.2 megagrams. We know by now that our formulas, or for you to be able to use this mass, you need to convert it to what? To Newton. But the formula of Newton, it is kilograms multiplied by meters per second squared. Now, we then have to convert this megagram, this M, it is for million, it is mega, to kilograms, so that our SI unit can suit the requirements of converting the mass into Newton. Now, here we will have 3,200 kilograms. K it's 1,000 multiplied by 1,000 it gives us a million. Then we'll be having 3.2 million grams. Okay, multiply by 9.81, then we get our W. All right, then we get our W Newton there. All right, now let us then calculate the F effort. In calculating the F effort, the formula that we need to use, it is mechanical advantage equals to F load over F effort. Okay. Uh, the question would be, do we have mechanical advantage? Yes, we do have. Do we have the FL? No, we don't have. We still have to calculate the FL because we are looking for F effort. Let us make F effort the subject of the formula. It will be F load divided by MA. We cross multiply. When we cross multiply, this is what we will have. All right. Now, in calculating the FL, it will be W over FL equals to big D squared over small d squared. Then we need to make FL the subject of the formula. When we cross multiply as well, FL multiplied by big D squared, small d multiplied by W, it will be W, small d divided by big D. Then our W, remember our W, it is this one. I didn't calculate it. We'll calculate it as we are calculating the FL. It is 3,200 multiplied by 9.81. Now let's make an emphasis here. Please read the given instructions carefully. If they say use the gravitational force as 9.8, use the gravitational force as 9.8. If they are saying use the gravitational force as 10, you then have to use the gravitational force as 10. But for the sake of this revision, we'll use the gravitational force as 9.81 since, well, the questions in our books, they've used 9.81. But read the instructions carefully so, all right, as per the instructions of your exam. All right, it will be multiplied by small d would be 0.08 squared divided by big D, it is 0.4 squared. Then our answer for FL, it will be 1,255,68 Newton. We've managed to calculate our FL. We can then substitute our FL in this formula in calculating the F effort. FL 1,255,68 divided by mechanical advantage, it is 40. Then we get our F effort as 31,392 newtons. Right. This is how we calculate that question, the equation A. Let us look at question B. Question B, they want us to calculate the distance the load will be raised after. No, here we are given the number of pumping stroke. Now we are given n here. For number of pumping stroke, it's 125. It doesn't have the SI unit. They want us to calculate the distance. Now in calculating the distance, we'll be using this formula. The fact that our data, it is given as diameters, there's no need for us to convert diameters into, we will be using that formula. Efficiency equals to power out over power in, or work output over work input. All right, what is it that we know? We know that work done would be pressure multiplied by what? By volume. Now, one of the characteristics says volume does not, pressure does not depend on the size nor shape of the container. Volume, it depends on the substance itself, meaning on the liquid or oil or whatsoever. Meaning pressure on the plunger equals to pressure on the ram side. Now, in this case, pressure and pressure will cancel out using this formula. It will be pressure multiplied by V out over pressure multiplied by what? V in. Pressure and pressure will cancel out. Then our efficiency, we assume that it is what? 100% multiplied by 100. 100% will cancel out with 100%. That means we will be having 1 equals to V out over V in. Then when we cross multiply, we'll be having V in equals to V out. Then from here, it is pressure. It is here, it will be area stroke length, number of strokes equals to area multiplied by height on the ram side. Okay, this is plunger. The in part of it, it will be the plunger, then the out would be the ram. But there's no need for you to convert the diameters into the area. This formula, it is still applicable. Small d squared, by the way, the the pi and the pi will cancel out. 4 and 4 will cancel out. Hence, this formula, it is applicable as well. dln equals to big D squared multiplied by h. Then we make h the subject of the formula. It will be small dln over big D. This is the formula that we'll be using to calculate the height. Okay, now we are having h equals to small d ln over big D squared. Small d 0.08 squared multiplied by stroke length, it is given as 120. It is 0.12 multiplied by 125 divide by 0.4 squared. Don't forget to square your diameters because it is taken from d squared from pi divided by 4 equals to pi multiplied by d squared. You know, the 4 and the 4 will cancel, pi and pi, then you'll be left with small d big D there in that formula. Now, hence I'm saying don't leave out, because you can't leave out the squares there because the diameters are not the same. Right now, you can't cancel those two. You need to put those two there, those squares there. Then our answer there, it is 0.6 meters. This would be 600 millimeters. This is how you calculate the second question there, where they said the distance the load will be raised after. Then the last one, the work done by the press, if the efficiency is 90. They want us to calculate the work done. Now, in calculating the work done would be force multiplied by height. The distance that the mass moved, it is the distance that we've calculated, the 600. The force would be the force of, or on the ram side, that would be your W. It is 3,200 multiplied by 9.81 multiplied by the height that we have calculated, 0.6. Then we get our work done as 16,951 kilojoules. This is how you tackle these hydraulic equations. Thank you, good people.